All right, today we are officially on the first section of Chapter 5. Remember, we just did a preview section just to kind of warm us up, be thinking about factoring, and of course using our identities. So here we go. First up, this should look familiar. This is very similar to Chapter 4, but of course we're going to have to be using some of our identities. So I'm going to draw our triangle because as you can see, we're going to be on the special right triangle by the lengths of those sides. So again, we're using that all students take calculus to figure out which quadrant to draw our triangle in. Now, as a review, all students take calculus is where the functions are positive. Everything's positive in 1, sine's positive in 2, tan's positive in 3, cos positive in 4. Well, we have a positive cosine, so that could be in 1 or 4. And then I'm going to narrow it down by the fact I have a positive square root of 3 over 2 for sine. So I need both sine and cosine to be positive. So I'm going to have to draw it in 1. Since they're both positive, everything's positive there. So that's how I'm going to figure that out, and I'm going to label the sides. Cosine, of course, adjacent hypotenuse. Sine, opposite hypotenuse, which we really only need the opposite. Now, once you have, of course, all of the sides on the triangle, you can list any of the trig functions we need. They want all 6. Well, clearly, I'm just going to use my identity information to get secant, because secant's the reciprocal of cosine, so 2 over 1, which we're just going to put 2. I can do cosecant without having to look at the triangle, just my identity information, because it's the reciprocal of sine. And of course, we're going to rationalize our denominator. We never leave a radical in the denominator. That's where that's come up a million times. So the only thing we really need, of course, is tan. So TOA, opposite over adjacent, which of course is root 3. And as always, we're going to do the reciprocal, and then we would rationalize it out. So the other way you could have done this, because clearly I didn't need the triangle for secant or cosecant, I did those straight off of the given information. Believe it or not, you could have done also tan off the given information if you didn't want to make the picture, because don't forget, tan is sine over cosine. And we know, of course, sine is root 3 over 2, and we know cosine's a half. Well, when you divide by a fraction, you multiply by the reciprocal. Oh, root 3, that's what we got. I don't care how you get the answers, as long as you can find everything they're asking you for. In that case, of course, all 6. All right, so let's draw the triangle, of course, if we need it. They give you functions, so you should be able to do the reciprocals right off the bat and get the other 2, so you should have 4. But let's go through if you want to use the triangle too. So I'm using my all students take calculus. Tangents positive 5/12, so that narrows us down to 1 and 3. Secant. Now, we like to work in the main 3 trig functions, so I'm going to go ahead and do the reciprocal of that. And more importantly, cosine's negative. So if cosine's negative, that's going to eliminate quadrant 1 because everything's positive there, so I'm going to have to draw it in 3. All right, tangent, of course, opposite, adjacent, and hypotenuse would be 13, 5, 12, 13, our Pythagorean triple. So I'm going to look to see what else I need for functions. If we know tan, I'm going to go ahead and list cotan. Again, I don't even need the triangle for cotan. I'm just going to do the reciprocal of tan. So it looks like we are missing sine and cosecant. So sine, of course, opposite over hypotenuse. And then cosecant, we can just do the reciprocal. Got it. Okay. All right, let's take a look at a couple more. Again, good review from the last chapter and using our identity skills for this one. So here comes an identity, cosecant of negative x. That's one of those even odd identities. Cosecant is odd, so that's going to equal the opposite. So the opposite of negative 5, 5. Now, I don't like that it's cosecant. We like to work in our main 3, so I'm going to go ahead and do the reciprocal of 5 and list out what sine is. Okay, now I'm ready to draw the picture, figure out where my triangle is going to be. Again, sound like a repeated record here. All students take calculus. Sine, of course, positive 1/5, so that's going to put us in either 1 or 2. And I'm going to narrow it down, of course, by the next piece of information. It says cosine's positive. So where is both sine and cosine positive? Well, it's going to have to be here in number 1. Because cosine's positive, of course, in 1 and 4, and you can see I have both the green and the red circled on all the everything. So I'm going to label our sides, sine, of course, opposite, hypotenuse. Now, you might be thinking you're going to have to do Pythagorean theorem, but I'm like, wait, they also gave you cosine? So you know adjacent hypotenuse. Now that square root of 24, I took that from the book clearly. Not a fan. Really, we should simplify that down. 4 times 6 is 24, square root of 4, 2. Because I'm going to have to simplify my answers, of course, so I'm going to go ahead and do that right now. So we've got, let's circle what we have. We've got sine, so there's 1, 2, 3. We could do secant right now without even having to look at the triangle, because secant, of course, is a reciprocal of cosine. Instead of that root 24, though, I'm going to put the simplified version, and then I'm going to rationalize it. So on the numerator, I'm going to have 5 square roots of 6. My denominator, 6 square root of 6, square root of 6, 6. 2 times 6, 12. So there I've got 4. Clearly we need our tan and then cotan. So I'm going to look at the triangle for tan and cotan. Tan, of course, opposite over adjacent. Again, instead of the square root of 24, I'm going to use the simplified version, and then we'll rationalize it. So on the top, I'm going to have the square root of 6. Denominator, again, will turn out to be 12. Cotan, let's just do the reciprocal. Be smart here. I'm going to do the reciprocal of the original fraction, because when I flip it, 2 square roots of 6 over 1. And of course, who needs over 1? There we go. So we do have now all 6 functions. All right, one more to go. So tan is undefined. As soon as we see undefined or even 0, I know I cannot draw a triangle. So I'm guessing it's going to be one of our quadrant angles, the points. So unit circle, radius of 1. If we drew a circle, we'd go right 1 and then 0, up 1, left 1, and down 1. And don't forget our ordered pairs from last chapter. Go alphabetical order, cosine, sine. Now, I'm going to start with tangents undefined. Undefined, 0 under the line. Our points only have cosine and sine. So here's where your identities come into play. Tangent, of course, is sine over cosine. So I'm going to go around the 4 points and see when I do sine over cosine, which ones turn out undefined fractions. So I'm going to start on the right point here. If I do sine over cosine, 0 over 1 is 0. That's not undefined. So not it. Cross it off. Okay, top point. If I do, again, don't forget your points are alphabetical. If I do sine over cosine, 0 under the line, undefined. That works. I'm going to circle it up. If I do the same on the left point, sine over cosine, 0 over anything, 0. Not it. Or if I do the bottom one, negative 1 over 0, that is undefined. So I'm looking at the top and bottom points. Now, it's not going to be both. We're going to narrow it down. The second piece of information narrows it down for you. Sine's greater than 0. Positive. Well, it can't be the bottom one because you have sine is negative 1. It's not positive. So we're going to work off the top point. So I can already list cosine 0, sine 1. So let's put those down. And we already have tangent, of course. So let's go ahead and do secant. Now secant, remember, is 1 over cosine. 0 under the line, undefined. That's going to be my final answer. If I know sine, I can do cosecant. 1 over sine. Got it? We need tan, of course, and cotan. Well, we have tan, I'm sorry. We need cotan. Let's get that one. So cotan, of course, is cosine over sine. So cosine of our point is 0, sine is 1, 0 over anything, 0. So I do have all 6 answers. I have the 5 listed here, and they already gave me tangent in the given information. So I'm not going to rewrite that one again. So very similar to chapter 4, just you having to use your identities a little bit more. Okay, so the better you know the identities, of course, the better this is, the easier it will be. Co-functions, everything's got a co. Co-function of sine, cosine. Co-function of cosecant, take the co off. Co-function of tan, cotan. Co-function of secant, cosecant. Co-function of cotan, it's already got the co, take the co off. And the co-function of cosine already has the co, take the co off. So just a quick we should know our cofunction identities, just reviewing, just practicing. Okay, match the trigonometric expression with one of the following. So using your identities, definitely need your sheet out, of course. This is similar to the warm-up section that we started on. So tangent times cosecant. Now there's a couple different identities on your sheet for tangent. 1 over cotan, sine over cosine. Does it matter which one we use? It kind of does. Now, if you're not sure and you're a little stuck, remember the pro tip, always try to rewrite everything in sine and cosine. So I'm going to rewrite tangent. I'm going to use the sine over the cosine. In cosecant, I'm going to go 1 over sine. I'm like, okay, all right. So my sines are going to cancel. I'm down to 1 over cosine. That's easy enough. 1 over cosine, secant. So it's got to be letter A. All right, let's take a look at B. So again, identities. This is an identity. This is under the Pythagorean identities. We haven't used those a ton. You're going to start seeing them more and more this chapter. Look under Pythagorean identities. 1 minus cosine squared is sine squared. So straight off the sheet. Cosecant, we know this one, 1 over sine. And now I can reduce. I've got sine squared over sine. We can take a sine out of everything. So we'll be left with sine. So letter F. All right, and the last one, let's take a look here at C, identities. Co-function on the top, because remember, pi over 2 is the radian form of 90 degrees. We just practiced those co-function identities. So here we go, co-function of sine, cosine. The co-function of cosine, take the co off, sine. Cosine over sine is also in our quotient identities, cotan. So letter C. Got it. It's kind of nice when you have the matching options so you have a little bit of choices to make sure you're on the right track here. All right, let's do some more. We just have some different choices for our answers, of course. So cosine squared, secant squared minus 1. Secant squared minus 1 is an identity. It is on your Pythagorean on the top, on the back of your sheet. Secant squared minus 1, tangent squared. Now, again, if you're like, oh gosh, I'm not sure what to do, leave everything or write everything in terms of sine and cosine. I'm going to leave cosine squared. Tangent we know is sine over cosine. And all I'm going to do, since it's squared, I'm going to put squareds on everything. Keep it balanced. Cosine squareds cancel. We're left with sine squared, which we can see is letter C. All right, B. So same thing, multiple choices on identity sheet for cotan, 1 over tan or cos over sine. Again, try to rewrite everything in terms of sine and cosine if you're unsure. So I'm going to use cosine over sine. Secant, of course, 1 over cos. Our cosines cancel each other out, so I'm down to 1 over sine, which of course we all know is cosecant. So letter A. All right, C. Another co-function identity. Don't let the squared throw you off. We're just going to put squared on ours. Co-function of cosine, take the co off, sine. And of course it's squared, so we're going to say squared. So I don't see that among our choices, so clearly I have to do some more work, even though it's in sine and cosine. So here's where you have to kind of have some good algebra skills. Sine squared, we can think of that as sine times sine, of course. And I still just have my cos on the bottom. So now I'm looking at this, I'm like, oh, sine over cosine is an identity. Sine over cosine is tangent. So now I'm looking among my choices, and I was like, oh, here we go. Yeah, it's in a different order, but who cares? It's going to be letter D, because the order we multiply in clearly doesn't matter. You could reverse those, and we'll get the same thing. All right, and the last thing we're going to do here, the only difference is you are not giving a matching selection of choices to pick from. You just have to simplify them. So same thing, same process. I'm going to try to rewrite everything in terms of sine and cosine if there's no obvious identities. So I'm going to leave cosine of beta, really a times between them. Now tan, you have a choice. 1 over cotan, sine over cosine. Again, since we have a cosine, I would use the sine over cosine. And you can see the cosines cancel, and we're down to sine. Got it. Okay, let's take a look at B. Now, identity. Bam, hits you in the face. That's on your Pythagorean identities on the back of your sheet towards the top. 1 plus tangent squared is secant squared. I still have cosine out in the front here. Now, I think I can simplify some more because clearly secant squared and cosine are related. Now, we could make cos 1 over secant. We could make secant 1 over cos squared. Choices. I don't care. We'll get the same thing. I'm going to make cosine 1 over secant. And I'm going to leave this secant squared alone. I can take a secant out of both expressions. I'm going to leave my final answer secant. Just to show you, you would get the same thing. I just want to show you. If you left your cos alone and you made secant squared 1 over cosine squared. The cosines, of course, would cancel. 1 over cosine, secant. Any way you cut it, we're going to end up with secant. It's just a matter of how you get there. Choices. All right, last two. So again, secant, we only have one identity for that. That's 1 over cosine. Same for cosecant, 1 over sine. Only one identity. When we divide two fractions, we end up multiplying by the reciprocal. So I'm going to flip that bottom fraction, put sine on the top, 1 on the bottom. Clearly the ones cancel. And we should know this one. This is a popular one. Sine over cosine, of course, tangent. All right, D, last one. So again, identity. Cotan squared plus 1 is on those Pythagorean identities. You're going to see a lot of those coming at this chapter. 1 over cotan squared plus 1, cosecant squared. Now, I can write that even a little simpler because 1 over cosine squared is sine. So I'm going to put my final answer is sine squared. Got it. So have your identity sheet handy. You're going to be looking at those Pythagoreans probably the most. Use those a ton. They're going to start coming up more and more. All right, have a great day.